Imagine a seemingly innocuous scenario. You're in a lab, a sterile environment, and someone proposes a thought experiment. What if we placed a black hole, no bigger than a grain of sand, onto a table? It sounds like a harmless, even quaint idea, a tiny speck of ultimate density. But the universe and the laws of physics have a dramatic way of shattering our assumptions. This isn't just a thought experiment, it's a cosmic horror story waiting to unfold, all from a speck you could barely see. First, let's clarify what a black hole truly is. It's not an empty void, but a region of space-time where gravity is so intense that nothing, not even light, can escape. This extreme gravity arises from an immense amount of mass compressed into an incredibly small space, forming a singularity. The boundary beyond which escape is impossible is called the event horizon. Its size is defined by the Schwarzschild radius, which depends directly on the black hole's mass. This is where our thought experiment takes a terrifying turn. When we say a grain of sand-sized black hole, are we talking about its mass or the size of its event horizon? This distinction is absolutely critical. If we meant a black hole with the mass of a grain of sand, it would be utterly microscopic, far smaller than an atom. Such a tiny black hole would evaporate almost instantly due to Hawking radiation, a theoretical process where black holes slowly lose mass. It would be gone in a flash, posing no threat. But that's not the scenario we're exploring. Our thought experiment specifies a black hole with an event horizon the size of a grain of sand. Let's say its radius is about 1 millimeter. To have an event horizon of that size, the black hole would need to possess an unimaginable amount of mass. Calculations show that a black hole with a 1 millimeter Schwarzschild radius would have a mass roughly equivalent to that of our moon. Yes, the entire moon, compressed into a sphere just 2 millimeters across. This is no longer a harmless speck. The moment this lunar mass black hole touched the table would cease to exist. It wouldn't just break, it would be instantly spaghettified and consumed. The black hole's immense gravity would tear apart the atoms of the table, pulling them into its singularity. But the destruction wouldn't stop there. The black hole would immediately accelerate downwards, unimpeded, through the floor, through the building, and through the very crust of the Earth. Nothing could stop its descent. As it plunged towards the Earth's core, the black hole would begin to accrete matter at an astonishing rate. It would consume rock, magma, and metal, growing larger and more massive with every passing second. Its gravitational pull would become the dominant force on our planet. Within minutes, the Earth's internal structure would be irrevocably disrupted. Earthquakes of unimaginable magnitude would rip across the surface. The planet would begin to deform, its very shape warping under the black hole's influence. In a matter of hours, perhaps a day at most, the black hole would have consumed the entire Earth. Our vibrant blue planet, teeming with life, would be reduced to a super-dense, incredibly hot accretion disk swirling into the tiny, insatiable maw of the black hole. What would be left? A slightly more massive black hole, now containing the mass of the Moon plus the Earth, silently drifting through the void where our home once orbited the Sun. The solar system would have lost a planet, replaced by an invisible gravitational anomaly. This chilling thought experiment serves as a powerful reminder of the extreme nature of black holes and the delicate balance of cosmic forces. A seemingly small change in scale, from mass to event horizon size, transforms a harmless concept into an apocalyptic event. It underscores the profound difference between our everyday intuition and the mind-bending realities of astrophysics. The universe is full of wonders, but also of forces so immense they defy our wildest imaginings. And sometimes, those forces can be packed into something no bigger than a grain of sand. Subscribe now and let's together explore the mysteries of humankind, nature, universe, and beyond. Together. Suggestions and ideas are also most welcome.